Hello, everyone. So yesterday we learned about combinations for day, or not yesterday, day 6, we learned about combinations. And last week we learned about permutations, but today we're going to combine the two and how you can differentiate between solving if it's a combination calculation or if it's a permutation calculation. And again, this little picture down here, just down below, it might be good for you guys to write down to help you differentiate between the two, so you can pause it and write it down. I'm going to continue moving forward. So in our warm-up today, it's saying how many ways are there to choose 3 separate office holders, chairperson, secretary, and treasurer, from a group of 5 people. So, one question you want to ask yourself is, first we got to figure out if we're doing permutation or a combination calculation. Does order matter in this question? The answer is yes, because these different people hold different positions. They're not the same position, they are different. So we know that our order will matter. We know our N is 5, and our R is 3 because we're dealing with 5 people and we're picking 3 of them. So I'm going to draw out our 3 slots here. We got our chairperson, secretary, and treasurer. And we have 5 different ways to pick that chairperson. Now, if we already picked the chairperson, we have 1 less person, so we have 4, and that's going to continue on for a treasurer. And 5 times 4 is 20. 20 times 3 is 60. So we know there's 60 different ways. Now, for this next one, it's asking how many ways are there to choose a committee of 3 people from a group. So now we'll ask, is it combination? Oh, this was permutation, by the way, up here. Now down here, are these people, is the order going to matter? Like, to determine if it's a combination or permutation. So we have 3 people from a group of 5, and we're choosing committee members. So they're all holding the same position. So remember with that one, we know that's a combination. Think combination committee problems. We have 3 slots. We have slot 1, slot 2, and slot 3 for the 3 different people that are going to be chosen for a committee. Okay, so for the first person, we could have 5 different possible outcomes for that first person. And this is going to be our permutation up top because this is just our numerator. So then we have 4. It's going to be very similar to that first question up top. So we have 60 as our permutation. But then we have to divide by the total number of ways we can arrange those 3 positions. And we know that is just 3 factorial. 3 factorial is equivalent to 6. So now we have 60 over 6, which is just going to get you to equal 10. So there's 60 different ways for permutation calculation, and there's 10 different ways for combination. Remember, a combination is always going to have less ways than a permutation. On this next slide here, it's just giving you that, it's showing you that a fruit salad is a combination because no matter how you have them arranged by the order, that order does not matter. So it could be bananas, grapes, and apples, or grapes, apples, bananas, and it's still going to be the same fruit salad. So that's how we know it's a combination. But now below it says the combination for the safe is 4, 2, 7. Now we do care about the order because 2, 4, 7 is not the same thing as 4, 2, 7. So we know that's permutation because order does matter in permutation. Now we're going to get some practice with deciding if it's a combination or a permutation. So if we have 4 people lining up in a picture, we know order does matter in this case, so we know it's permutation. And how to calculate it, we can just take 4 factorial, because we've had a lot of practice with permutations by now, so we know 4 factorial is just 24. Now for part B, Mr. Feig is going to pick 4 students from first hour to help him clean his room. Okay. And it's, first there's 4 students and there's 20 total. So now we know that is a combination because the order of how the people are picked does not matter. So we know it's a combination. And that's going to be, let's see, 20 factorial, because that's our n, over 4 factorial times 20 minus 4 factorial. For the sake of time, I'm not going to go and calculate it. Just know that's how you would set the problem up with calculating. Now for part C, we're choosing first and second place in a race. There's different positions. First and second, there's different rankings. So we know it's a permutation because order does matter. And then we'd set that up as our n factorial, which is 10 over 10 minus 2, which is 8 factorial. So that's how you would set that one up. Now we're choosing 3 out of 5 candy bars to buy. Does our order matter? If you pick a Twix and, let's see, a Twix and a Reese's, is that different than picking a Reese's and a Twix? No, so order does not matter. So we know that is a combination. And to solve it, we have 5 factorial over 3 factorial times 5 minus 2 factorial. So that's how you would go about solving that one. And then for part E, it's having you pick the top 2 horses in a race. So this one, it's not having you pick first and second place like different rankings. It's just having you pick the top 2. So let's say you picked it's out of 6. So we know n is 6. R is 2 because we're picking 2. And we know it's a combination because that order does not matter with how you pick the 2 horses. So we know that it's going to be 6 factorial over 2 factorial times 6 minus 2 factorial. And that's how you'd go about finding that one. Part F, we're choosing a treasurer and a manager. So does order matter? Yes, it does, because we're picking 2 different positions. So if you assign someone to be a treasurer and a manager, that's different if you were to flip their positions around. So we have n is 9, and our r is 2 because we're picking 2 people. So we have, so this would be a permutation. 9 factorial over 9 minus 2 factorial. Last but not least, we're selecting 2 co-captains for a baseball team with 9 players. Does order matter in this? No, it does not, because they have the same position. They are co-captains. So we have 9 factorial, because that's our n value, times over 2 factorial, times 9 minus 2 factorial. So again, you will be needing to know for your quiz how to differentiate between if you're knowing it's a permutation calculation or a combination calculation. And your homework will help get you practice with that. And then once again, your homework and homework quiz are on Schoology. Again, feel free to ask questions.